All right, guys, it is now November the 4th, 2020, and we are continuing on with the last lecture for ABGs, or blood chemistry, acid-base chemistry, oxygen transport. All of that will accumulate today with a review and some classwork. I was hoping that we'd have more people on by now, but we got to keep on going. There's one thing I want to add to the lecture, just one little aspect that we didn't cover, and I want to make sure we cover it because you may see questions that have those as choices. So I'm going to go ahead and share my screen. And it's simply right here at the hypoxia part. The hypoxemia part. We talked about how, this is determines hypoxemia with PaO2 of 79 to 60 is mild hypoxemia, and 59 to 40 is moderate, and severe is less than 40. Okay, that doesn't change. When it comes to total O2 content, 18 to 20 volumes percent is normal. So when you get to 17 to 15, that's mild. 14 to 12 is moderate, and less than 12 volumes percent is severe. Okay, because they may give you a choice to say which one of these mean severe hypoxemia, and they may only give you either 1, 2, 3 right here or 1, 2, 3 right here. Okay, so you got to know both of them. Okay, now I told you don't worry about this 60-year-old stuff, but this one here. Now, those other ones are understood that the patient is on room air. Okay, if they're on room air, that's the values. Okay, that's normal. But if they're on oxygen, then now you are in a state of, did you correct the hypoxemia? Did you overcorrect the hypoxemia, or have you still not corrected the hypoxemia? All right, because that's why we give oxygen, to correct or treat hypoxemia. Okay, that's the only reason we give oxygen, because your oxygen level is low, which is hypoxemia, right? And so we give you a little oxygen. So say we have given Mr. Johnson a little oxygen, and now he's on 28% oxygen and not 21, which is room air. Okay, if he's on 28% and he still has a PaO2 of less than 40, you wouldn't say severe, you would say uncorrected. Okay, because you're trying to correct it. You gave him some oxygen and it's still low. So now it's still uncorrected. All right, so what will we do? Bump him up some, right? Give him some more. Let's give him 40% oxygen. Go back and get another ABG. And now his PaO2 is 69. It's still uncorrected, okay? It's going to be uncorrected until you get to normal, all right? So say you got some oxygen, you gave him 40% oxygen, and now it's 69. His P(a)O2 is 69. It's still uncorrected hypoxemia. You don't have to say mild, moderate, severe if they're on oxygen. Only time you say mild, moderate, and severe is if it's understood that they're on room air. Every time you get an ABG, it's going to tell you what the patient is on. Patient is on room air, all right? And if they don't tell you it's on room air, you assume they're on room air, okay? The only time that you won't know that they're on oxygen is if they tell you, all right? They have to tell you the patient is on oxygen or not. And if they don't tell you, then you assume that they're on room air, okay? These labs are drawn on room air. So right here it says, if the patient is on any FiO2 other than room air, then you must answer in the following terms. It's either corrected hypoxemia, uncorrected hypoxemia, or overcorrected, okay? So say Mr. Johnson is on room air, right? He's on room air, and you gave him, you got an ABG, and his PaO2 was 30, okay? You would say he's severe hypoxemia, right? Because he's on room air. But, so then we say, okay, let's try to fix this, right? And so we put him on 40% oxygen. and then we give him 40% oxygen, and we get another ABG, and his PaO2 is still 70. You would say uncorrected hypoxemia because we have given him some oxygen and it didn't fix the problem. Okay. Say you say, okay, now we bump him up to 50% oxygen, and now his PaO2 is 85. Then you call it corrected. Okay, we have finally corrected hypoxemia. Okay, the only time you say mild, moderate, severe is if they're on room air. If they're not on room air, then you have to let me know, did you correct it, or is it still uncorrected, or did you overcorrect it? Because 80 to 100 is normal. What if you put him on oxygen? He was 70, right? PaO2 of 70, so that's mild hypoxemia. Okay, and you give him 3 liters of oxygen. You come back and get another ABG, and now he is 150. His PaO2 is 150. Well, you have overcorrected. Okay, you just simply say he is overcorrected because it shouldn't be more than 100. Okay, if it's more than 100, you have overcorrected it. Now, it can be over 100 if they're on room air, and that's simply if they're hyperventilating. Okay, if somebody's taking a whole bunch of deep breaths, he's sucking in all his oxygen, right? So his PaO2 may be a little higher, maybe 105, 110, something like that. That's about as high as it would ever go on room air. But you can give somebody oxygen and his PaO2 be 300, 250. That's way too much. Okay, you're gonna learn that when we talk about our peds, our babies, if you give them oxygen that makes their PaO2 go above 80, you can blind them, okay? Because everything exerts a pressure. Gases exert their own pressure, right? Right? Okay? And so since we talked about 21%, when you change it into a pressure, is 159 millimeters of mercury of pressure, right? And so everything exerts its own pressure, and which we will deal with that on this next, after this test, we'll be getting into that, talking about that more, what you've already talked about. But in a baby, in his retina, that gas is there, and that pressure is pressing on the retina, which damages the nerves, okay? And the blood vessels are blocked, become ischemic and necrotic, right? And once that happens, it cuts off the circulation to his retina. And then when that happens, the body will try to fight that and start making new blood vessels all of a sudden. Amazing, just start making new blood vessels. But they're made so fast that they bust and rupture. And that's what causes the blindness, okay? That's called retinopathy of prematurity. And so you'll learn that that's one of the hazards of oxygen therapy. We talked about yesterday another hazard of oxygen therapy. What did I tell you yesterday was a hazard of oxygen therapy? But you got to be careful. Too much oxygen to a who? To a COPD patient, because they only live to be what? Hypoxic. They want to be hypoxic. They have to be hypoxic in order to breathe. Okay, if they're not hypoxic, they're not going to breathe. And so if you bump up their oxygen too much, they're no longer hypoxic. You have overcorrected, or you have corrected their hypoxemia, right? They want to be hypoxemic, but you have corrected it. So now they stop breathing. So that's one of the hazards. There's a few hazards you're going to learn about oxygen, because everything is good, but too much of anything can kill you. All right, even water. All right, so when they're on anything other than 21% or room air, then you have to answer the oxygenation part of the ABG as corrected hypoxemia, uncorrected hypoxemia, or overcorrected hypoxemia. Okay, so if it's above 80, and if the PaO2 is above 80 and they're on oxygen, then it's it's corrected. Okay, you have corrected it. The normal value is 80 to 100. So if it's over 100 and they're on oxygen, then you have overcorrected it. Right? It's just like you only would spank your child if they're doing something wrong. Okay? You're trying to correct them, right? Or you only would punish them or take their phone or whatever y'all do these days. We spank, but I don't know what y'all do these days. But if you take his little phone or make him sit in the corner and he still does the thing wrong, then he's uncorrected. You try to correct him by taking his phone, but he's still doing it. So you have not corrected the problem. All right. You spanked him or whatever, and now he doesn't do that anymore. You've corrected that problem. Okay. So what if you take his phone and then he's the best kid in the whole wide world? Too much, right? You've overcorrected him. Okay. So that's what we give oxygen for. That's the only reason we give oxygen, is to correct hypoxemia, to treat hypoxemia. That's one of the 3 reasons we give oxygen: to treat hypoxemia, which you'll hear this again later when we get to oxygen therapy, to decrease the work of the heart and decrease the work of the breathing. Okay? Decrease the work of breathing, decrease the work of the heart, and to treat hypoxemia. That's the only 3 reasons we give oxygen. Okay? Because we've learned that when the oxygen is low, the heart has to work harder and the lungs work harder, right? You're breathing harder, shorter breath, because your body has a lack of oxygen. Okay? Not that you're not pulling in the same amount of air, is that the oxygen is not transferring. And so the body makes you feel like I'm short of breath. And when they're short of breath, it's because their oxygen is low. Okay? And so when we give them some oxygen, we give Mr. Johnson some oxygen, and then we get another ABG 30 minutes later. Okay? And we see what the P little a O2 is. All right? Or do an O2 content 30 minutes later, right? Either one will give us some numbers. And if they're on oxygen, anything other greater than 21%, then when you answer that question, you must answer it in one of these 3 terms. All right? So I don't want to, I'm recording that. So people who are not here yet, if you come in and we answer some questions, you're not going to know that. Okay? So that's that part. We talked about the regular on room air. This is what the O2 content should be. We talked about that. All right? So if I have a Mr. Johnson, say I got Mr. Johnson and he's on room air and his total O2 content is 13 volumes %, then what is that? Moderate hypoxemia. If it's 13 volumes %, it's moderate hypoxemia. Okay. What if I have him on 40% oxygen and he's on a FiO2 of 40% and his total O2 content is 13 volumes %? What would I say? That's if he's on room air. He's on 40%. Uncorrected. I'm giving him oxygen, trying to correct this hypoxemia, but I haven't, right? I'm not giving him enough because I'm not correcting it. It's not in normal range. Okay? What if Mr. Johnson has a total O2 content of 19 and he's on 40% oxygen? Correct it. Correct it, because it's now in normal range. 18 to 20 volume % is normal range. So if it's 19, it's normal. Okay. What if I put him on oxygen and his O2 content is 32? Overcorrected. Too much. Cut it down because it can damage him. Okay. Too much oxygen can cause oxygen toxicity. All right. And all these other things. So that's that. All right. So I just want to make sure you guys understood that. And now we're going to start with some NBRC questions, NBRC type questions. All right. These are some sample NBRC questions that will come from the board exam in this section. So this will be some that will come. This is a type of question that will definitely be on your board exam. Okay, that comes all the way back from RT 210, right? This is after 210, 220, 230, 240, 250. Then you go sit for the board exam and hear a question from 210. You got to know ABGs, period. Okay, so everybody work on that. I'm gonna pause the video while you work on that. All right, so number one, just so I give you some terms, interpret the following: blood gas drawn on a patient from a breathing patient breathing 21% oxygen. That's room air. Okay, room air. He has a P little a O2 of 117 torr. Remember, torr and MMHG are the same. He has an S little AO2, which is saturation of arterial oxygen, which is the SAT, right? That will be up on the board or on the pulse ox finger on your finger of 98%. He has a pH of 7.57, a CO2 of 20, a bicarb of 24, and a base excess of +1 milliequivalents per liter. Told you won't have to deal with that base excess that much, so answer the question. What all apply? What all apply? Knowing what you know about corrected, uncorrected, or overcorrected hypoxemia, okay? But in this case, he's not on oxygen. He's on 21%. He's just on room air, okay? So how would you answer number 1? Only time you use corrected now is if they're on oxygen. So don't let that fool you. Are you on? Or you can't get on? You on Zoom? I let you in. I don't remember. Okay. Remember, I told you that your P little AO2 can be a little higher than 100 on room air if you're doing what? What did I say? What could cause that? Breathing hard. If you're hyperventilating, okay? And so one of those terms down there show you, yeah, he's hyperventilating, right? Okay. So which ones would you pick? All right. So what did you get? C. Okay. What y'all get? What you get?
I ain't try to, but I know it's normal oxygen.
Okay. What you get? You say you're confused? A. Okay. All right. So the answer is C, 1 and 3. The reason why it's not 2 is because I told you, you only use the word corrected when they're on oxygen. He's around 21%. That's room air. Yeah, so he's room air. So that's not corrected. That's out. You can take 2 out. Okay. And then the ABG itself, pH is 7.57. What is that? Alkalosis. So we are in an alkalosis for sure. Okay. And so that takes 4 out. But we're not in the acidosis. We're in an alkalosis, right? So if we take 4 and 2 out, only thing left is C. Okay. But when you, and that's how you need to learn how to take these tests, eliminate what you know for sure you can eliminate, and that will take away some of the choices. Okay, but so I told you that you can have a P little a O2, guys, of a little bit more than 100 if they are hyperventilating, and in this case he is hyperventilating because he has a CO2 of 20. So that's low. That's respiratory alkalosis, all right? Because pH is 7.57, that's alkalosis. Now let's see who's causing the problem. Well, CO2 is 20, that's alkaline. Bicarb is 24, that's normal, right? So respiratory is causing the problem. So it's a respiratory alkalosis, right? Then we look at the third player. Is the third player out of normal range? No, so it's uncompensated. He is not trying to compensate. So it's uncompensated respiratory alkalosis with normal oxygenation. Okay, so that's what you would say. Only reason his P little a O2 is a little high is because he's hyperventilating, and it shows in the ABG. He's hyperventilating, he's blowing off too much CO2. He's hyperventilating. Okay, all right. And when you hyperventilate, it causes you to be hypocapnic, right? Low CO2. All right. Look at number 2. Interpret the following blood gas drawn on a patient breathing 60%. Now, this patient is on oxygen. Okay? He has a P little a O2 of 72 torr. He's statin 94%. A pH of 7.18. CO2 of 50. And a bicarb of 18. Base excess of -10. So what are we looking at? He's on oxygen. He's on oxygen. So knowing that he's on oxygen, there's only one choice. There's only one choice there to choose from. Which one is that? Before you even break down the AB, we're still gonna break down the ABG. But before you even do it, what do we know? He's on 60%. So his PaO2 of 72 is what? He's on oxygen. It's not corrected. Uncorrected. It's uncorrected. It's not normal. He's on 60% oxygen. And so if it's on 60% oxygen and his PaO2 is still 72, it's uncorrected. So there's only one choice to choose from in all of those choices. What's the answer? I'm talking about down at the bottom. What's the only choice you could choose? A, the only one with one in it. So you know it's uncorrected hypoxemia, right? And so, okay, I know it's uncorrected hypoxemia because it's 60%, okay? So when I look at it, the only choice down there that has that in there is A. The rest of them don't even include one. And if they don't include one, they can't be right. Okay, they can't be right. So it's got to be 1 and 5. Okay, so let's look at it. What is pH doing? Acid. What is CO2 doing? Acid. What's bicarb doing? Acid. So it's a combined acidosis. So it's combined. Remember I told you if all of them are going the same way, it's a combined acidosis, right? Sometimes they'll say combined metabolic and respiratory. They're just trying to show you that the combination, but you don't even have to say metabolic and respiratory. You can just say combined acidosis. Okay, so that is combined acidosis with uncorrected hypoxemia. That's what that is. Okay, but you got that. Y'all know how to do. You just did the ABG. Remember I told you yesterday, if all of them are going the same way, if they're all acid, it's combined acidosis. If they're all alkaline, it's combined alkalosis. Okay. Huh? Oh, okay. Yeah, if they're all the same, it's combined. It's called combined acidosis or combined alkalosis. You got that? Did you get that? Okay. All right, so I'm saying you got to take your time and break it down one thing at a time. Remember, to an ABG is two components: a acid-base component and a oxygenation component. It's two different components, so you need to just break them down. Looking at this patient, he's on 60% oxygen, and his PaO2 is still not normal, so it's uncorrected hypoxemia. Okay, so we know that part. I think you can. Mm-hmm. Mm-hmm. Just don't forget to go back, because if you submit without going back, you missed all those questions. And it's 100 and something questions, so don't forget to do that. So yeah, so he's on 60% oxygen. We know that it's uncorrected hypoxemia. Okay, we know that. All right, and so we know that part. So we know one has got to be in the answer. All right. So when I look at my choices, I go on A, and I'm through with that one, right? Because I know that one has to be in the choices. But if I didn't know, and I just didn't know that, I just go ahead and keep working it down. Well, pH is acid, so we're in a acidosis. So we have to see who's causing the problem. Well, CO2 is 50, so that's acid. And bicarb is 18, it's acid. So we are all three acid, so we are a combined acidosis. Okay? Combined acidosis with uncorrected hypoxemia. Okay? Yeah, I will a little bit in a minute. I just did that. Look at number 3. Interpret the following blood gas on a patient breathing 24% oxygen. So he's on oxygen, 24%. He has a P-little-a-O2 of 57. He's statting 91%. pH is 7.45. CO2 of 22. Bicarb of 16. Base excess, -6. So get your oxygenation status first. Find out what that is so you understand what that is first. He's on 24% oxygen, so he's on some oxygen, okay? And his PaO2 is still 57. So what is that? I mean, okay, but what is that first though? Because the answer is C. Good. Okay, but I want to know if he's on oxygen and his PaO2 is still 57, what is that? Uncorrected hypoxemia. So okay, number 2 has to be in it. Okay, 2 has to be in it. So we are down to a choice between C and D. Okay, because A and B ain't it. So C and D. All right, so let's see. C is, let's just look at the rest of the ABG. pH of 7.45 is what? Normal but leaning. Good. Normal but leaning alkaline. Okay, so let's see who's causing this little pool, this little lean. CO2 is 22. What is that? CO2. No, don't just say what somebody else says. CO2 of 22, alkaline. 35 to 45 is the range. Less than 35 is alkaline. Okay. CO2 of 22 is alkaline. All right. Bicarb is 16. What's bicarb doing? Acid. So who's causing the problem? CO2, because it's the one that matches pH. Okay. So we are in a respiratory alkalosis. Now, let's look at our third player. Is our third player, which is bicarb in this case, is he in normal range? Huh? No. So he's trying to compensate. There is compensation going on. Now, was his compensation enough to pull pH back into normal range? Huh? Yes. Because it's 7.45, right? So his compensation was enough to pull pH back into normal range, so that is completely compensated or fully compensated respiratory alkalosis. Okay? Fully compensated respiratory alkalosis. So it looks like 3, compensated respiratory alkalosis. And what was it? Uncorrected? So 2 and 3. Answer is C, like you said. This is how you have to break down ABGs. And once you get, you're doing them and you're practicing them and you're seeing them, it's second nature. And it's fun because now you know what to do. When I look at this, I know what to do. Okay? I know what to do. Yeah, but don't let that bother you. Don't. And the only when I pulled this up, I saw correct and said, "Damn, I don't think I talked about that. Let me make sure I cover that." So it is new, but it's simple. If the PaO2 is not in normal range and they own oxygen, it's uncorrected. Okay. So the uncorrected part is if you have a patient that is breathing oxygen, not room air, any other FiO2 other than room air. You look at the PaO2. If it's still not in normal range, then it's uncorrected. You try to give oxygen to correct a problem. But if it ain't in normal range, you didn't correct it, so it's uncorrected. You don't have to say mild, moderate, severe. You just say uncorrected. If they're on oxygen and the PaO2 is in normal range now, like 85, something like that, then you have corrected it. That's corrected hypoxemia. All right? If you got them on some oxygen and their PaO2 was 150, 200, 300, it's overcorrected. You got to back down off that oxygen. Okay? All right. Last one. Interpret the following blood gas drawn when the patient was breathing 35% oxygen. So he is on oxygen. His PaO2 is 86. He's sat in 90%. pH of 7.29. A CO2 of 37. And a bicarb of 17. And a base excess of -8. What do you have? Patient is breathing 35%. So it's not room air, he's on oxygen. And his PaO2 is 86. Satting 90%. pH of 7.29. CO2 of 37. Bicarb of 17. You got an answer, Ms. Rose? What you get, Ms. Rose? You got A? Anybody else got an answer? You got D in the dog? Okay, what you get? A? What you get?
No,
Not sure?
I know it's
Okay. The answer is B.
what?
Well, that's what they got. Let's look at it and see. Because they could be wrong. All right, so patient's breathing 35%. So he is on oxygen. His PaO2 is 86. So we do have corrected hypoxemia. So one is right, okay? Definitely one. So it's either B or D, okay? And D, so yeah, because y'all putting A. A is, you got uncorrected hypoxemia. Huh? Yeah, he's breathing oxygen. He's breathing in 35%. What is room air? 21. Anything greater than 21, he's on oxygen. Okay? So if he's on oxygen and his PA2 is normal, then that's what? Corrected. Corrected hypoxemia. Okay? Corrected hypoxemia. Now let's look at the rest of it. A pH of 7.29, what is that? Acidosis. So we're in acidosis. Okay. Now let's see who's causing the acidosis. CO2 is 37. What is that? Normal. Bicarb is 17. What is that? Acid. So who's causing the problem? Bicarb. So that's metabolic acidosis. Now, the third player in this case is CO2. Is CO2 in normal range? No. CO2 is normal range. It's 35 to 45. CO2, PaCO2, regular range, right here on the board, 35 to 45. Yeah, make sure you get them right now, because they'll throw you off. CO2 is 35 to 45. So what is CO2? Normal, right? So it's uncompensated. He's not trying to compensate. So if the third player in this case, which is CO2, he's in normal range. So he's not trying to compensate. So it's uncompensated metabolic acidosis with corrected hypoxemia. Huh? Oh. Yeah. All right. Y'all got the ABG parts together. I mean, you know your ABGs, I guess, because the way it's worded, the way it's set up, that's just how it's going to be. You're going to have to know, pull out what you know. Follow the steps. What is pH doing? Who's causing the problem? Is the third player compensating? Yes or no? If he is he fully, or is he just partially compensating? All right? The oxygen part should be the easiest part. PaO2 is either mild, moderate, severe, and if they own oxygen and it ain't normal, it's uncorrected. Okay? That should not be too hard. All right? I think you're just overthinking it, and like you know the answers. So don't let it second guess yourself. All right. Let's look at some let's take a break. 8:50, come back at 9 o'clock. We're going to continue on with classwork. All right, so we're back from break, and I want to explain one thing that we talked about, lab error. Don't forget, we discussed lab error on the last lecture, that if one of the players has to be going the same way as pH. If they're not, it's a lab error. For instance, if I say a pH of 7.5, that's alkalosis. We are in a alkalosis, okay? But if my CO2 is 80, that's acid, and my bicarb is 10, that's acid. That can't happen. That is a lab error. Throw it away, restick, and do it again. You may have to calibrate your ABG machine or something like that, okay? But that can't happen. All right. One of them has to be going the way it's pH. All right? Now, all right, so next part we're going to do now is I'm going to tell you an ABG, and I want you, if you're on here, you're in the chat, which I don't have anybody that's at home. I don't think. Nope. So I'm going to tell you guys an ABG, and I want you to just come on the board and draw me one. It doesn't matter the numbers as long as they match what I say, okay? For instance, if I say, show me a combined acidosis, then you would say, okay, anything with a pH of acid, any CO2 that's acid, and any bicarb that's acid, and you're done, okay? Doesn't matter if yours is different than somebody else's. As long as it's a combined acidosis, that will be correct, okay? When you take your oral exam, it's going to have a couple of lab errors on there, and then they're going to tell you, cite me an ABG that's respiratory acidosis. And you'll have to tell them, okay, any pH less than 7.35, any CO2 greater than 45, and that's respiratory acidosis with a normal bicarb, okay? And you don't have to even tell them a number, just anything greater, anything less, right? You know your numbers. I'm going to leave those up, but I want you to be able to tell me an ABG, okay? So we'll start with Ms. Thomas. Erase what? Oh, now you should have them, but I'm going to leave them up there. Just don't look. Yeah, just don't look. I'm not gonna. You gonna come up here, so you're not gonna see it. All right. Ready? Any color you like. All right, Ms. Thomas is going to show us a. Show me a fully compensated metabolic alkalosis. Fully compensated. You might want to write it down. So you're fully compensated metabolic alkalosis. Just take your time. And y'all can be writing one, one yourself. Fully compensated metabolic alkalosis. Fully compensated metabolic alkalosis. Okay, let's take a look. Huh? No. All right, so fully compensated metabolic alkalosis. So she put these numbers up. Let me stop the share so both can see. So, fully compensated metabolic alkalosis. Now, what is pH doing? It's normal, but leaning what? Alkaline. So we're in an alkalosis. We're in an alkalosis. Now let's see who's causing the problem. What's CO2 doing? It's 34. Alkaline, 34. Good. So it's a little alkaline, right? So alkaline. What is bicarb doing? Alkaline. So what is this going to be? Combined. This would be a combined alkalosis. All right. If you wanted a fully compensated, then a metabolic alkalosis, then metabolic will be alkaline, pH will be alkaline, but CO2 would be acid. It would be acid trying to compensate for that base, right? Trying to bring that base back up. So if we had a CO2 of about 45,
so a 50 would be acidosis.
yes. No,
So
they lean. If they don't lean, it's got to be out of range. Only thing that leans is pH. Okay? So if we had a pH of 7.45, that would be normal alkalosis, right? And then we see who's causing the problem. Bicarb is 28. That's alkaline. So that would be a metabolic alkalosis. Metabolic alkalosis, right? And then we look at the third player. The third player in this case would be CO2. CO2 is not in normal range, right? So there is compensation. There is compensation. Now, was his compensation enough to pull pH back into normal range? Yes, so it's fully compensated metabolic alkalosis. Okay? Get it? Okay. So you just have to think. When you're doing it, just one thing at a time, pH. And I know what I want, so let me make that true, right? All right, next. Ms. Rose, show me a partially compensated respiratory alkalosis. Partially compensated respiratory alkalosis. And here it is right here for me. Partially compensated respiratory alkalosis. Alkalosis.
Alkalosis. Okay, I gotta write my better.
All right. Okay. So partially compensated respiratory alkalosis. So in this case, when something is partially compensated, there is compensation, but the compensation was not enough to get pH what? Back into normal range. So this would have to be greater than 7.45. It'd be like 7.5. Okay. Now we're in a alkalosis, right? So this means we are in a alkalosis, and I want a respiratory alkalosis. So you said 32 right here, so that's fine. That's alkaline. That puts us in a respiratory alkalosis. Now, in order for compensation to be going on, the third player has to be out of normal range, right? So by far would have to be out of normal range, and it have to be lean and have to be which way? There you go. So it has to be like 16. Okay? So look at this. pH is 7.4. If we're looking at it like this, 7.5 is alkalosis. We are in an alkalosis. Now, who's causing the problem? That will be your second player. CO2 is 32. He's alkaline. Bicarb is 16. That's what? Acid. Okay, so CO2 is causing the problem. So it's a respiratory alkalosis. Okay. Now, the third player in this case is the bicarb. So is he in normal range? No. So there is compensation. There is compensated, right? It's compensated. But was his compensation enough to pull pH back into normal range? No. So it's partial. Partial compensated respiratory alkalosis. Okay? He is trying to compensate, but he wasn't enough. Okay? So whenever there's partial compensation, pH not going to be in normal range. Okay? All right. Taylor? All right, I want you to show me. Show me respiratory acidosis. Show me just straight up respiratory acidosis, uncompensated. Respiratory acidosis. All right. Good. pH is what? 7.32. That's acidosis. All right. Now let's see who's the second player causing the problem. What is CO2 doing? Acid. What's bicarb doing? Normal. So who's causing the problem? CO2, which is respiratory acidosis and uncompensated. Okay. All right. So the regular ones are a little bit easier, but the ones when you got compensation is when there's a problem. Okay, you ready? You want to do one? Or I'm not ready. If you're not, all right. Show me a metabolic alkalosis. Okay. All right. We'll move on. All right. Very important that you guys stay abreast to the lectures, studying, reading. This ain't nothing to play with. I know we got other things to do, kids and all of that, but this has to take your time right here, because if not, it's gonna blow by you, especially this part. Okay, this is a very important aspect of it. All right. What we're gonna do now is I want to work on some sample questions. I'm gonna throw out a word, and I want you to tell me, be able to explain it to me, if you can. Okay? I'm gonna say a word. I want you to tell me what it is. All right? You don't know to say I don't know. But that's what y'all want to work on tonight, these vocabulary words. All right. Miss Rose, what does affinity mean? Affinity. Love. And so we do that in terms of what? Whose love for what? No. When we talk about affinity, we talk about hemoglobin's love for either oxygen, CO2, or carbon monoxide. Okay. And speaking of affinity, how much more affinity does hemoglobin have for oxygen, for CO2 than it does for oxygen? 20 times more. And how many times more carbon monoxide does he love it more than oxygen? 200 times. That's why people die of smoke inhalation. Okay? Carbon monoxide poisoning. All right, Kayla, carbonic acid. What is carbonic acid? Not sure? Anybody can help her with carbonic acid? What plus what gives us carbonic acid? Plus. Yeah, well, H3CO2 is your carbonic acid, but it's formed by water plus bicarb. That's all you need to know. Carbonic acid is a combination or the hydrolysis of bicarb. Bicarb added to water. So HCO3 plus H2O gives us H2CO3. Okay? That's carbonic acid. Water and bicarb. Water and bicarb come together to form carbonic acid, right? And when you would just talk about the bicarb over the carbonic acid, is in what reference to what equation? Henderson-Hasselbalch equation, which is pH equals pK plus the log of bicarb over carbonic acid. That's how we get 7.4, right? Okay, good. Kayla, what about the tell me the Haldane effect. Do you know the Haldane effect? And you're going to get these terms tonight, so you'll be able to go through and look them up. I'm just going through them now, so you can write them, as you learn them, and then tonight will be an easy assignment. So it's not like you have to know it right now. It's okay. It's okay. Transport. The effect of oxygen. The effect oxygen has on CO2 transport is the Haldane effect. Okay. All right. You ready? Can you tell me what the Bohr effect is? The Bohr effect. Okay. Anybody? It's for CO2. Yes. So it's the effect of CO2 on hemoglobin's love for oxygen, right? CO2 get out of jail, guess what? Oxygen got to go, right? She's gonna drop him. He's a good guy now, but you got to go. I like CO2 way more, right? And so the effect of CO2 on hemoglobin's love for oxygen. Good. All right. What about, Ms. Rose, what does alkalemia mean? Alkalemia. You can just tell me a reference number of pH. Good. That's alkalemia. Alkalosis, right? Kayla, what's acidemia? pH lower than 7.35. Good. All right. All right. Ms. Thomas, what about a chemoreceptor? What is a chemoreceptor? The chemoreceptor, there's two sets. Can you tell me one of them? Central, good. And what's the other? Peripheral, good. Central chemoreceptor and peripheral chemoreceptor. The centrals respond to an elevated CO2. Remember, central CO2. Elevated levels of CO2 in the cerebral spinal fluid, and the peripheral chemoreceptors respond to a low oxygen or hypoxia. Okay. All right. And the next one was CSF, but that's cerebral spinal fluid. The next one was Henderson-Hasselbalch equation. Just told me that. All right, Ms. Rose, what is hypoxemia?
Hypoxia is the deficiency of oxygen in arterial fluid.
Good. Kayla, what's hypoxia?
Decreased oxygen in the tissue.
Good. All right. What happens with Ms. Thomas? What happens with histotoxic hypoxia? Cyanide poisoning. Ms. Rose, what about anemic hypoxia? Anemic hypoxia is anything that has to do with the problem with the hemoglobin, right? And so if carbon monoxide comes around, hemoglobin is going to drop everything and hold on to that. So that will be carbon monoxide poisoning. So anemic hypoxia will be an example of carbon monoxide poisoning. Okay. We just did respiratory acidosis, combined alkalosis, partially and fully, central chemoreceptor, peripheral chemoreceptor. Let's see. And that's, a couple more I didn't say, and I'll let you do on your homework tonight, but that's good. Good. All right. All right, so let's work on some of this here. Oh, CO2 transport quiz. Not 4th grade, but I want you to work on this quiz. We're going to work on 1 through 4, and then I'm going to move on, okay? So you'll be online. Everybody can see. Get your scrap piece of paper out. Work on 1 through 4. Try not to use your notes because tomorrow's your exam. Try not to use your notes, but if you have to, you have to. If that helps you study it, that's fine with me. But the less you use, the more you know, okay? And if you're not sure, don't just look it up and put it down. Try your best to figure it out. And if all else fails, you can't figure it out, either leave it blank and I'll go over it, or you look in your notes, okay? But try your best. Work on 1 through 4. I'm going to pause the recording while we work on 1 through 4. Number 1 is 80% of carbon dioxide is transported how? Number 2, what causes saying something? Oh, yeah, I'm going to put it up there. What effect causes the unloading of CO2 from the hemoglobin in the lungs? What effect? I'm looking for effect, okay? Number 3, what is the normal PaCO2 range? And number 4, write out the Henderson-Hasselbalch equation, okay? You don't have to solve it, just write out the parts of it. Okay, let me share my screen for you. 1 through 4, I'll pause the recording here. Mr. Clay, we are working on 1 through 4, writing on a piece of paper. I'll go over it after some time has gone by. 1 through 4, and then after that, we're going to move on up to, I think it goes up to, let's see, to 10 of them, and I have the answer. So 1 through 4 right now, and then we'll do 5 through 10 after that. Y'all still see my screen? Okay. Y'all put y'all's pencil down. I know y'all done with those 4, and I can move it on up for you. Take all your time. All right, going up to 5 through 8. Did it move for y'all? Did it move to 5 to 8 for y'all? Okay. 5 through 8. Ready? Okay. All right. What's 9 and 10? That should be easy. On 9 and 10, we're gonna take a break, come back and go over the break, and then we're gonna play Cahoots. It's an online quiz game. All right. All right, so I'm going to now go on break. It's 9:40. Come back at 10 o'clock. 20-minute break. And at the top of the hour, 10 o'clock, we will start our Kahoot review game, which I'll put up on the screen what website you need to go to, the Kahoot, and it will join the green. You can make up your own fun name, and it'll go. We'll start, and we'll see, what percentages of who's winning the game, okay? So go ahead, take your break. Come back at 10 o'clock, and we will play the Kahoot game. I'm going to pause the recording at this time. If anybody's online, I'm pausing now. Come back at 10 o'clock. Mr. Clay, can you hear me? Okay, what I'm going to do is I'm going to now put up the Kahoot. I'm going to share my screen, but you'll need to go to that online, okay? When I give you the link, you're going to go to that. It's a special code. I don't know if y'all played it before, but there's a special code. Put that code in, it's going to link you straight to my game, okay? And then I'm going to push play. You're going to hear the music, and we're going to just answer the question, okay? Read the questions carefully. Some of the questions I pulled exactly from the an alternate test, okay? Straight from the test. You won't be able to see it again, of course, but it's trying to help you as much as possible. But you're going to have to buckle down tonight with these ABGs. As much as possible. After this Kahoot game is over with, if you have any questions about ABGs, then I can go over some ABGs with you. After the Kahoot game is over with, I'm going to stop the class. That's going to be the end of the class. We've gone over everything again, answering some of this classwork. A lot of students said they like more classwork. I put it in and I only have a few people to show up, either live or on here. Okay, Joshua, you're the only one that showed up outside of being here. So, I can't make you do it, okay? Now, so we're going to push. Let's go ahead and make sure I do this right. If you have an issue with logging on, you don't have to say, I can't log in. It just is what it is, okay? Answer questions the best you can, on a piece of paper, because I'm going to share my screen for the questions, okay? So for some reason it can't log your answer or whatever, just write it on a piece of paper, but it should work. Last time I had a little glitch here and there, but it's 15 questions, okay? 15 questions. You can get a scrap piece of paper out for the ones that may have to do a little calculating. But other than that, let me get it set up. All right, y'all should be able to see my screen. I'm gonna click the acid-base chemistry, RT210. All right, let's see here. All right, so it's loading the PIN number. Go to www.kahootit, www.kahoot.it, Kahootit, and here's your PIN right here. So as you log in, it's going to assign yourself a name. You can be some kind of silly name. Like I said, last time I did this, why y'all got this? Got any more scrap paper? Oh. You don't have to log in. You don't have to log into me, but you do have to log in to the Kahoot. Yeah, go ahead. Yeah, I just thought you need some paper. I'm like, y'all using scrap paper now. I use clean paper if you want. All right. www.kahoot.it. All right, and then you put in this PIN number 114805, and it's gonna your name will pop up, and you make up a name, right? You can be like I told you, somebody was asleep with me last class and had WAP, and I'm calling them WAP all day long, and I didn't know what it meant until somebody told me a little later. My daughter told me. All right, so keep it professional, guys. Okay, keep it professional. We got one player named Beans. We don't know who it is. We don't have to know. Okay, that's why they do that, so you don't know who's getting all the right answers and who's losing all the right answers. Okay, got one player in. Marie is in. Huh? I guess so. RT leader is in. So we got 3, 1, 2, 3, and I think Joshua's on there. So if he's in there, he'll be loading in. Give him a little bit more time, because Joshua, are you there yet?
Yes, I am.
Oh, you already in, so he must be one of the other ones. Okay, because Lily is in. Lily. Okay, that's it. That looks like everybody, because that's all we have that's present. 4 people. All right, when I put start, the game is going to start. All right. Try to answer them as quick as you can, because I'm pretty sure I changed the time on most of them, but it might be one that I should have been a little more time and didn't give you much time. So try to answer it as quick as possible. When it pops up, I'm going to read it, but you can be reading it too. Okay, here we go. Now, I also have to pause recording. Captain Koala, Captain Wallaby, you have won our acid-base Kahoot. Good job. Who was it? Your prize is free homework for tonight.
What?
Free homework for tonight. You don't have to turn in a homework for attendance tonight. All right, good job, guys. That's going to end our class for today. We've reviewed, we've gone over this. Tomorrow, what's tomorrow? Thursday. Yeah, tomorrow is your exam. Tomorrow is your exam. I will answer any questions you have to start before the class starts. But we got to get it in, because we have to pick up the next lesson, which is gas physics, and talking about oxygen cylinders, which is kind of one of the easier ones. This test coming up, oxygen cylinders, is one of the easier ones. Just kind of memorizing the cylinders, how long they last, and stuff like that. Other than that, you are dismissed. If you have any questions, you can ask me now. The homework for tonight, I'm going to put it in. It's going to be that vocabulary list that we went over today. Don't forget, we talked about that study guide. I told you guys to work on that study guide last night. And if you had questions from the study guide today, I would go over that, but nobody asked me that. But you can ask me now if you got them. If not, I will see you guys tomorrow morning for a last little 5-10 minute session of review, and then you're going to take the exam. Do what? The quiz. Oh yeah, let me get that out. Where was that at? Yeah, let's do that. So let me share my screen. All right, so I'm sharing my screen. This was the quiz we took in class today. Let me move my computer and stuff back down. My back is banging. Number 1, 80% of carbon dioxide is transported how? As bicarb. As bicarbonate. All right. Number 2, what causes the unloading of carbon dioxide from the hemoglobin to the lungs? The Haldane effect, because we said the Haldane effect is oxygen's effect on CO2. So that is the Haldane effect. When oxygen increases, then the hemoglobin will unload the CO2 into the lungs, okay, so that you can do what? Exhale it, all right? When that hemoglobin returns to the lungs, it's meeting oxygen. It's a lot of oxygen that you just breathed in, right? And that oxygen says, okay, well, hemoglobin says, well, now I will release the CO2 now into the lungs and pick up the oxygen so I can take it back to the body. That's known as the Haldane effect. It's the effect of oxygen on the transport of CO2. And so the key in this one is unloading of CO2 from the hemoglobin, and where is it doing it? In the lungs. That's where high amounts of oxygen will be found, in the lungs, okay? Number 3. Number 3. What is normal PaCO2? 40 millimeters of mercury, or if you said 35 to 45, that would be fine. That would have been fine. But if you have these choices, you pick the choice that's best, right? But 40 millimeters of mercury, that's the normal PaCO2 with a range of 35 to 45. Number 4, write out the Henderson-Hasselbalch equation. pH equals pK plus the log of bicarb over carbonic acid. And how is carbonic acid formed? Yeah, water and bicarb. What is that process called? When you combine water and bicarb, what is that process called? What's the process called? Henderson-Hasselbalch equation tells us what happens, but what is that process called? When you add water or mix water with bicarb, that process, when they fuse together, that's called, there you go, hydrolysis. Hydrolysis, right? Carbonic acid is formed by the hydrolysis of bicarb, okay, added water. And then speaking of that, the normal bicarb to carbonic acid ratio is 20 to 1. 20 to 1. Now, that's saying 20 of bicarb to 1 of the carbonic acid. If you have a 10 to 1, then pH will tend to be what? If you have 10 of the bicarb to 1, acidic, more acidic. And if you have 30 to 1, you have 30 of bicarb to 1 of the carbonic acid, it will tend to be more alkalosis or alkaline. Excellent job, guys. Excellent. Number 6, what's the purpose of the buffer system? Maintain that pH. Number 7, what is hypercapnia? Too much carbon dioxide, or you might be specific, CO2 above the normal limits, or CO2 above 45 millimeters of mercury. What's hypercapnia? Oh, what causes? I'm gonna say that. That's 2 questions. There you go. What causes hypercapnia? Hypoventilation. If I don't blow off enough, my CO2 is going to get higher and higher and higher, because hypercapnia is high CO2. And what causes the high CO2 is my hypoventilation. Okay. What about hypocapnia? What causes hypocapnia? There you go. There you go. And there you go. And that is CO2 below normal limits. Excellent job, guys. So this is there. It's being recorded. So, you know, you can go back and look at the quiz and these answers right here. Okay.
Number 17, what does a value of less than 300 represent?
Now, hold on. Where is that at? Number 3. The study guide? Yeah. Let me pull up the study guide. Seemed like somebody asked me that once before. I wasn't sure what they were getting at, but I think I did figure it out, and then I forgot what it was. But let me look. Study guide. All right, let me do a new share. Y'all talking about this form here? Oh, okay. Assignment study guide.
It's like homework number 5.
Yeah. Okay. What does it say? Discuss. Oh, what number are you talking about? 17. Okay. Oh, so this one I have a 17. Okay. All right. Let me Let me look at my homework. Homework number 5. Because it might be in reference to a question before that one. Is that D? Or we in E? Okay. Oh, for the exam, oral, and final review? Okay. Number 17. What does a value of less than 300 represent and greater than 300 represent? So let me see what's before that. Normal PA, O2 gradient. What is the normal? What is normal room air? Just disregard 17. I forgot what they were talking about, but that's not enough information to know. I don't know what they're referencing in that too. So don't worry about that. When I find out, I'll tell you, but that won't be a test question. All right. So I'm gonna pull up that 17. Yeah, you don't have to memorize all the values. What number is that you talking about? 32 says normal ranges for venous values. Yeah, like I say, you don't have to memorize them all, but just know that they're which ones are close to our arterial. So the question, guys, is from homework number 5, number 32, which says, know the normal ranges for venous values. So I have a student asking me a question about number 32. And I told you in the lecture that you don't have to memorize them all, but you do need to know that which ones are closer, like which values are close to arterial blood gases. There were 2 of them that I said are really close, and I can use those if I want to just know ventilation, right? But if I want to know oxygenation, I have to use the ABG. So the 2 that I could use to, if I have to get somebody who's getting stuck all the time, if all I'm concerned with is the ventilation, then I can look at the pH and the CO2. All right, remember that the pH and CO2 are very close. Exact what they are is in your lecture. Okay, it is in your lecture. So just remember what the pH and the CO2 is. Okay, I'm not going to ask you what is the venous CO2. I'm not going to ask you that question, but you do need to know for yourself that they are fairly close. So if all I'm concerned about, Kayla, is whether he's ventilating or not, I can look at a venous blood gas, okay? Because the CO2 in the venous blood gas and the CO2 in an arterial blood gas they're kind of close. I think it's like 46. And the venous is about 46, right? And ours is 35 to 45. And so the pH, I forgot what it is exactly, but I can look at those 2 and say, yes, he's ventilating well, or he ain't ventilating, okay? But when I want to know oxygenation, I can't use a venous because the pressure of venous O2 is like 40, right? That's way lower than what it should be in arterial. Okay, you cool? All right, you good, Rose, on that one? Yeah. Okay, anything else? So it's good to have for our knowledge, but yeah, it's good to have for your knowledge, because you like out in the field where it's like 9 times out of 10 yes, but sometimes you can't stick. What if you can't get an artery? What if they're really, really overweight and you can't find that artery? You've been stuck several times, you can't get it. Sometimes you say, well, just give me something out the line. You know what I'm saying? I have to use a venous to but all I can do on the venous is know whether I'm ventilating or not, or if I'm in acidosis or alkalosis, okay? If I get a venous gas and its pH is 7.0, I know this person is suffering from acidosis. I don't have to get an ABG for that one, okay? If I want to know if they're ventilating and I get a venous and his CO2 is 46, he's ventilating, okay? But if it's 85, he's not, right? If his CO2 is 85 in a venous gas, he's not. That's way too high on either one, okay? He's not blowing it off. 15. Okay, normal AA gradient. We said the normal AA gradient is, in the notes, is 10 to 15 millimeters of mercury. All right. 10 to 15, I say really 0 to 15, because it might not be much of a difference. It might not be 10 whole different pressure, right? But just know that textbook is 10 to 15. The normal AA gradient on room air is 10 to 15. Number 7, how is most of oxygen carried to the tissues? Oxygen is transported 2 ways. Which way is the most? Combined with the hemoglobin, right? You got dissolved, or you have combined with hemoglobin. Those are 2 ways that oxygen is transported. Dissolved is how much of it in milliliters is dissolved into the plasma, which is 0.003 times the P little AO2, and that would give you the amount dissolved in the plasma in milliliters. Then if I want to know how much is combined or attached to the hemoglobin, remember the hemoglobin has 4 binding sites, and so oxygen clamps onto the 4 binding sites. And so you do 1.34 times the hemoglobin times the saturation that you see on the wall or the finger probe, okay? Remember, when you're calculating the saturation, you must do it as a decimal, not a percent. So 98% will be 0.98, okay? 99% is 0.99. 100% is just 1. Don't do 0.1, but that will be 10%, okay? 1. All right. Any other questions on the homework number 5 or any other homework that you've done on this section? That ABG sheet, that homework that had the ABGs, like I said, I didn't assign that one because a few of those were kind of like the one that your friend had, where they're expecting you to think about it leaning when it doesn't, they don't lean. And so it kind of throws you off, and I didn't want to make you do those, and I didn't go through and pick, you do this one, don't do this one, do this one. I wasn't going to do all that. Just practice ABG that, you know, that we've done in class. Yeah, but remember, guys, that it can be a lab error. If the pH is not going the same way of either CO2 or bicarb, then that's a lab error. One of them has to be leaning that, or one of them has to be matching what pH is doing. If pH is acid, then one of the other 2 players has to be acidic. If pH is alkaline, then one of the other 2 players have to be alkalitic. All right? Any other questions on these homework questions? So now's the time to ask if you wasn't sure.
Okay, explain central chemoreceptors.
Central chemoreceptors. How do the central chemoreceptors work? The central chemoreceptors, central CO2, central CO2. Think of that in your mind. What happens is the carbon dioxide freely. It flows freely through the cerebral spinal fluid, in and out. And the central chemoreceptors detect an increase or elevated levels of carbon dioxide in the central the central spinal, the cerebral spinal fluid, which is the CSF. The central chemoreceptors detect an elevated level or a low level of carbon dioxide in the cerebral spinal fluid. When it detects a high level, it will say, hey, you need to breathe. It reacts by making the body breathe. It sends a signal to your inspiratory neurons, your inspiratory centers, right, that we talked about, and tell the body, hey, breathe, okay? The peripheral chemoreceptors respond to hypoxemia. Whenever the patient is hypoxic, the peripheral chemoreceptors will respond by telling you to breathe more and the heart to pump harder, okay? The peripheral chemoreceptors have 2 types. What are they? Those are the 2 chemoreceptors, but the peripheral chemoreceptors are broken down to 2 carotid bodies and aortic bodies. The carotid bodies are found in the common carotids. When you have those carotid arteries that come up to the brain, in the little notches, the bifurcations are little booger-like structures, a little green little structure. They're just sitting there. and it's like a little sensor, and it's measuring the amount of oxygen in that blood. The carotid bodies will respond by saying, breathe more. The aortic bodies are little boogers that are on the aorta, okay? And when they sense hypoxemia, they tell the heart to pump harder, okay? And that's why it's on the aorta. Why would the aortic body not be on the pulmonary artery? Why is it on the aorta and not the pulmonary artery? No, I'm just saying, just think about those two arteries and what they do. And peripheral chemoreceptor is going to try to fix hypoxemia, right? So why would I place the carotid body, I'm not the carotid, but the aortic body, why is it on the aorta and not on the pulmonary artery in the heart? There you go. Pulmonary blood is deoxygenated, so it ain't gonna tell me nothing, right? It's already deoxygenated, but the aorta should be fully what? Oxygenated. Once that blood gets in that aorta to the body, it should be fully oxygenated. And that's the last step before it goes to the body. So if it ain't right, that little aortic body will say, hey, this ain't enough. And it's going to tell the heart, you need to pump harder, okay? And push more blood, all right? Anything else? I'll look into that 300 again. I know what it is. I forgot. I don't know what they're talking about. I don't think that's laminar flows or nothing, so I'll find out. But make sure you work on that. I gave y'all that quiz apart. It had the dissolved and the combined hemoglobins, how to calculate dissolved and combined. Make sure you go over it. I know if you did it already, do it again. Look at it, work them out. Make sure you know how to work out dissolved, you know how to work out combined, and you know how to work out total, right? Make sure you understand the hypoxemia levels when looking at just the total O2 contents. Less than 12 volumes % is severe, right? 18 to 20 is normal. Okay, so make sure you know those. Make sure you know the hypoxemia as it responds to, in terms of millimeters of mercury, right? The P little AO2, what's mild, moderate, what's severe. Don't forget the corrected, right? If they're on any FiO2 greater than 21% and the PaO2 is still not normal, it's uncorrected. You tried to correct it, but you haven't done enough, right? Make sure you think about those. If that's it, then that's it.
What time are we starting
We'll be prepared to be here at 8 o'clock. Like I said, I'm going to let a couple people ask me a couple questions before we start. You want to test? Yeah. I always do that. Once you clear your desk, like if your desk is sitting here right now, you're completely clear, then I'm gonna give you a blank paper. Here you go. And you can write whatever you want to write on it. Formulas, whatever, because it's from your mind. You can't look at it from something else and write nothing on it. But once your desk is clear, then you can write whatever you want to get it off your chest right quick before you forget, right? So if you want to put the formulas, you want to put left, everything to the left does this, and everything to the right does this, and this is my formula, my values for my PCO2, my ABGs, all my little values. If you memorize them, put them on the paper. It's not cheating. It's coming straight from your head, all right? And then we'll get started. So we should be starting no later than, I like to start no later than 8:15, 8:20. What do you mean, before you can get here? That's fine. That's fine. You'll have time to get it done. But after that, I want to start the next lesson, all right? So I need to be starting that next lesson at least by 5 after 9. All right, have a good day. Good job today. Good job. Okay, guys, this ends the lecture for today. Test is tomorrow. Study your study guide. Study your homework sheets that I have given you for this section. Make up some ABGs and tell yourself this is this is that. And then if you have any questions on the ABGs or anything like that in the morning, we will go over those for about 5-10 minutes, and then we got to go ahead and knock out this test. Knock out the test. We're going to then get started on our next lesson, which is gas physics, talking about bulk systems and oxygen tanks. That's one's going to have a lab to it. All right. So we'll talk about how that lab is going to go and all of that. because you have your next lab that you do will be on cylinders. All right. So good job today. Pretty fun. Nice review. Take your time and don't second guess yourself. And I'll see you tomorrow.